Hello guys, welcome back to LeetCode. Today let's practice a LeetCode hard question design graph with shortest path calculator. Although this is a hard question, it is not that difficult if you are familiar with some graph theory and some graph algorithm. So to find out the shortest path between two nodes, the first algorithm comes into my mind is the Dijkstra. But here in this video, I want to use the Floyd-Warshall algorithm. So in this algorithm, basically it's just say if you want to find out the path from node A to node B, then you can check all of the intermediate nodes. Like you can go from A to C and then to B, or you can go from A to D and then to B. So after checking all of the intermediate nodes and find out the shortest or the cost with the minimum cost, and then you can find out the cost, the real cost here. But in this video, I will just assume that you are already familiar with this algorithm. So I will just show you how to use this algorithm to solve this problem. If you are interested in the intuition and the theory behind this algorithm, you can check the link in my description part. I will put some other useful tutorials, YouTube tutorials there, and then you can learn more about this algorithm through that link. Okay, now let's go start coding part. Okay, so first let's make the n as a class variable, and to use this algorithm we have to use a two-dimensional matrix. Let's call it M. So for initially, all of the values in the matrix will be set to infinity number, which means there is no path from one node to another node, or from the row node to the column node. And the size of the matrix is the n. Okay, and then after that, the next thing is we will set all of the values in the diagonal of the matrix to 0. That means it equals 0, or it equals 0 from one node to the node itself. And then we will start to put the edge in the matrix. So what we have in the edge is the source node in the destination node and the cost. Okay, and then next is to start to try all of the intermediate nodes. So intermediate nodes, I will just call it J, call it K, and we will have n different intermediate nodes, because every node in the matrix can be an intermediate node for other nodes. And for every intermediate node, we will compute the shortest path from the source node through that intermediate node to the destination node. So the source node is I and the destination node is J. So here we will have a nested loop. And updates the cost. So from line 15 to line 16, I just update the cost, and then if I will check if it costs less if we go through intermediate node K, and then if that is smaller than its initial value, so that is lies in self-direct matrix I to J. If that is true, then we'll update the value in the I and J. Okay, so that is all for the init function, and then let's goes to the add age function. So whenever we add an age, maybe we have to update the graph. So first, let us unpack the edge. So we have the source and destination and the cost. So and then we will check if the cost here or the new added age, the cost here is smaller than the cost in the matrix. If that's true, then we have to update the graph. But if the cost is larger, then we don't have to update the graph, because we only want to find out the smallest path, right? So if that is bigger, then we don't have to bother to updating. And what is the original cost? So it lies in the matrix already. So if that is true, then we have to update. So I will just copy the code here. So if that is true, let's say we will. So the original path from A to B is A, and then to B. Sorry. So the original path is from I to J, right? And now we have a new path which goes from A to B. So we want to check if we go through this path, will it cost less? So that means if we can go from I to A and then to B and then to J, if this path, the cost of this path is less than the cost of this path, if that is true, then we will update the matrix here. So yeah, so here we want to go from I to A and then A to B. So the cost from A to B is lies in cost, and then we'll go from B to J. So here should be B to J. Okay, so that is all for the add age. And then for the find out the shortest path. So the value of the shortest path already lies in the matrix. We just have to take out the value from the matrix. Node 1 to node 2. Okay, so we will return the cost. But if the cost is infinity number, which means there is no path from the raw node to the current node. If that is no path, then we want to return -1 instead of an infinity number. So here we have to swap the value or change the value. Or here it should be K to J. Okay, let's run the code again and submit. Okay, pass. Okay, thanks for watching. See you next time.